Welcome to our channel. Today, we discuss a topic that sounds like science fiction but is rapidly moving toward reality: why 2065's quantum internet will completely rewire society. Imagine a world where information travels not just through wires or fiber optics, but via the very rules of quantum physics, allowing instantaneous communication across vast distances, secure beyond anything classical encryption can offer, and capable of powering technologies we can barely conceive today. This is not just an upgrade to our current internet, it's a paradigm shift in how we connect, compute, and even think about information. To understand why this is so transformative, we first need to grasp what the quantum internet is. Unlike the internet we use today, which transmits information as bits, zeros and ones, the quantum internet transmits information as quantum bits, or qubits. These qubits aren't just 0 or 1, thanks to a property called superposition, they can exist in multiple states simultaneously. That means a single qubit can encode exponentially more information than a classical bit. But the magic doesn't stop there. Qubits can also be entangled, which is a mysterious quantum phenomenon Einstein famously called spooky action at a distance. When two qubits are entangled, a change to one instantly affects the other, no matter how far apart they are. This is the principle that allows quantum communication to be fundamentally different and potentially infinitely faster and more secure than anything we use today. Now, you might be wondering, why 2065? Why not sooner? The truth is, the quantum internet isn't just about creating faster connections. It's about building a completely new infrastructure that can reliably manage qubits over global distances, maintain entanglement despite environmental interference, and integrate seamlessly with classical systems we already rely on. Current prototypes exist, like quantum satellites and fiber optic quantum networks in some countries, but scaling them to a global network is a monumental engineering and physics challenge. Experts predict that by the 2060s, we'll finally reach a tipping point where quantum networks aren't just experimental, they become the backbone of global communication. So what does a quantum internet mean for society? The most obvious impact is security. In the world of quantum communication, eavesdropping isn't just difficult, it's theoretically impossible. Any attempt to intercept a qubit would immediately alter its state, alerting the communicating parties to the breach. This could render traditional cybersecurity obsolete and redefine how nations, corporations, and individuals protect sensitive data. Imagine banks, governments, and even personal devices communicating with absolute confidence that their messages cannot be intercepted. This alone would trigger massive shifts in global politics, economics, and even social trust. But the implications go far beyond security. Quantum networks could fundamentally change computing itself. Quantum computers, which already exist today in limited, experimental forms, require quantum networks to reach their full potential. By 2065, these networks could allow multiple quantum computers around the world to link together, forming distributed quantum supercomputers of unprecedented power. Tasks that today would take centuries, simulating complex chemical reactions, modeling climate systems with perfect precision, or analyzing vast datasets instantaneously, could become routine. The consequences for medicine, energy, climate science, and AI research would be staggering. Diseases could be cured faster, new materials discovered in months instead of years, and climate prediction could reach a level of accuracy we currently can't imagine. Even everyday life could be transformed. The quantum internet could enable new forms of communication that feel instantaneous and immersive. We're talking about experiences that surpass video calls, virtual reality, and augmented reality. With quantum networks, virtual presences could interact as if they were physically together, sharing experiences and information without latency. Education could be revolutionized. Imagine classrooms where students from across the globe collaborate in real-time quantum simulations. Commerce, entertainment, social interactions, all would be reshaped by this new form of connectivity. Of course, no transformation comes without challenges. The energy requirements, ethical questions, and geopolitical stakes of a global quantum network are immense. Nations will compete for dominance in quantum technology just as they have in the digital era, potentially triggering new forms of technological tension or even conflict. Who controls quantum networks could dictate global power in ways we are only beginning to understand. There are also concerns about inequality. Will access to quantum resources be universal, or will it deepen existing technological divides? These are questions that scientists, policymakers, and society as a whole will need to grapple with as we approach this quantum frontier. Yet, there is reason for optimism. Historically, major technological leaps like electricity, the internet, and smartphones have eventually led to broader societal benefits despite early challenges. The quantum internet may similarly democratize knowledge and innovation, enabling breakthroughs in fields that today seem impossible. Collaborative projects spanning continents could accelerate at a pace never seen before, and human creativity could flourish in ways we can only speculate about.